Okay, so before the break, we kind of added an opponent into that game we started last week. We're just looking at the tools in this course. The second level, the SDEV 248 class, is where we really dive in and learn those in detail. And I wanted to make sure and look at everything in sort of preview mode, so y'all can get started doing stuff, and then that way it's not completely overwhelming when we do so much in 8 weeks, when we dive completely into Unity in 8 weeks time. But before we do that real quick, I wanted to express a point while the camera's pointing to the board here. For those who've had me in class before, have probably seen this, but whenever we go and we're going to make a project, right, we'll create a project proposal, has all kinds of stuff, information in there. It has like, what are we going to do? We'll have like our goal, the goal of the project, and a bunch of stuff there. We'll have the people involved, all right, contacts. And the proposal is going to have all kinds of information in there, right? Just this big, long, might be 5 pages long documentation written up talking about it. But when it really comes down to it, there's only 2 lines on there people care about. Whoops, if I can spell it correctly. The budget and the timeline. Hopefully that makes sense, right? In our world, if we don't turn in all of that, if we don't submit all of that information with our proposal, people are gonna think it seems a little inadequate or something. But really, all they care about is how much does it cost and when do they get it? And the thing is, both of those are as trivial as can be in a classroom, right? In a classroom setting, we're students, so our budget's pretty much always 0. And our timeline is due date. It might be a lecture example where it's just a few minutes, or it might be this week's homework, which is whatever the weekly due date is. But as trivial as can be in a classroom, in the real world, that's the only 2 lines people care about. So so we don't really need them in a classroom. So in classroom settings, and things like the final project in here, we're asked for a bunch of paperwork and stuff. It's a great place to practice those. As you sit down and make games for practicing in homework assignments in a class, or just your own practice those lines and try to get really good at predicting the budget and timeline, because that's the lines people care about. So if you get some practice in that and kind of develop a good skill predicting how much something's going to cost and how long it's going to take, people will really take notice of it. And that classic saying of get your foot in the door, right? The way we always want to get started. And game development, there's a lot of people want to get in there, so we got to do a bunch of stuff to get our foot in the door. But that will help you take that a step further, and once you get your foot in the door, actually kick down the door to make sure you stay in that place. Right? If you can just random practice, make up some numbers for your random practice on a video game, just make up some numbers and a schedule, and then put the thing together and see how far off you were from your initial guess. So then on the next time, you can improve that initial guess and get better and better and better at it. So then when you're out there actually trying to get well established as a career in game development, you'll immediately be known as somebody that's good at predicting the budget and timeline, which are the only 2 things people care about. And I'm gonna leave that money stuff up there for a reference point later. But I just wanted to make that. That's why I like to include paperwork in the classroom. Plus, the game dev is fun. Right? The classroom, we have to include the not fun part. We need to make sure and focus on the not fun part in the classroom setting as well. So getting back to what we were doing before the break, just going to kind of wrap up quickly here. Is, well, we've looked at all these interesting things Unity has in it, right? A whole bunch of the stuff over here on the UI that we can do, different panels, all kinds of stuff here, big fancy words that you probably haven't heard yet. Quaternions springs to mind. First place I saw that was in a 400 level math class. So I'm guessing you all probably haven't heard words that don't show up until 400 level math classes. It also shows up in 400 level physics classes. But if you haven't had those, you might not recognize those words. And Unity is going to seem overwhelming. But one thing about Unity is they use all the proper terminology. So once you've had got far enough along with studies in general, not specifically game development, but mathematics and physics and the general sort of thing and graphical design stuff, the stuff we are simulating with our games, then you will have heard all these words and know what they mean and things, like a raycast. That is the actual name for it. But unless you've formally studied graphic design in detail in some fashion or another, you probably hadn't heard that word, and it just seems like an odd word that Unity puts in there. We looked at collisions and animator objects and game objects and all these fancy things, but we've kind of skimmed over the trivial parts. So I wanted to include some here just to make sure they were included and lead into a tip I wanted to leave you with to wrap things up for this semester. So I'll just do hit points and experience points. Those are easy numbers that we're going to have in most games, right? We need some hit points so that when the opponent hits us, our health goes down, eventually reaches 0, means we lose a life. And there's some other effects that I'll talk about with my tip at the end. And experience points, so that as the game progresses and we've done more and more, it adapts to our skill, right? Level 5 is harder to get through than level 1. That way it keeps it interesting for the player. Right? As programmers, we're not the opponent of the player, we're on the player's side. And part of that is we want to make it interesting. So we don't want them to get bored halfway through the game because they've already mastered all the skills in level 1 just to get halfway through. So we need the game to increase in difficulty level to go with the player. So a couple common things we're going to have, and it's going to stick on the coding side, so we can just make them private. I'll just do integers. An int called hit points. We'll start that off with, I don't know, 100 is a good number. I was just throwing them in here for the concept. We're probably going to use hit points. Then a private integer called experience points, which is going to start at 0 because the player doesn't have any experience yet. And then those are like our normal business type of software that we would typically see in a software development course. We can do all our normal math with them, increase them, decrease them, which is really what we want to do. So for our example here, I'm just going to print them out. So here at the end of the update, which to keep the example simple, I was doing everything in the update here. Hopefully those who have had enough programming realize that it would probably be better to split this stuff up to its own functions. And for those who haven't had that much programming yet, eventually you will realize that it would be better to split that up into its own functions where the things are focused. So we'd have like a kick function separate from our update function that we just call here. And we'd have a move function separate from our update function that we just call from here. But I wanted to try to minimize clutter and putting it all in one place seemed like a good thing for the example. So we can do the same thing here. When we get to the end, I'm just going to throw it out to the console. Oh, for one. Yeah. I'll just print out hit points. Oops. I'll just print out those values on the console, though obviously it would be better to probably show them in a nice fancy user interface. But we saw UI stuff. It's fairly straightforward. And experience points. Whoops. A capital E there. And just keep that somewhat organized here. I'm just gonna, I'll put a row of asterisks afterwards to keep them separated. So that's gonna say what it does at each pass of the update. That way we can tell which one we're currently in. I'll leave that other part there. And now we just need to know when to adjust those. Nothing fancy. I was getting ready to go run a version of that, but all it's doing is we declared some variables and we're printing them out. So we might need to change them. And that is just our basic math stuff. So for an easy example on that, I'll just do it here. So if we make a collision with our blue guy while we're kicking them, we'll increase experience points. Experience points plus, increment those, and then we can start doing stuff with them. So now we should be able to see something when we run it. Come back over here, wait for it to compile. Clear that and give it a run. So you see it's kind of going through there, showing the hit points and the experience points. Nothing's changing on them, but if we come over here and kick this guy, there it goes. Might need some refinements there. Every time a bun initially collided, it pushed him back. So then when the kick happened, it wasn't continuing to collide. So what I was having to do there is I was having to keep walking into him while kicking. Is why that seemed to be throwing an error, but you can see our experience points went up. The trivial part, there's really not much to see there. All the things we would want like that. And then we could make adjustments so that as our experience points, maybe our experience points become a multiplier on that kick. And instead of just destroying the guy, we have to take his hit points down. And the more experience points we have, the more damage each one of our kicks will do. And that's just a scalar multiplier. Right? So like the collision.gameObject.hit points gets subtracted by experience points times 5 or something, some damage value. And just use that as a scalar so that our attacks do more damage. Similar thing with our hit points, and they can be inconsistent. And yeah, that part is kind of trivial, but I just wanted to include it somewhere and show that it really is just the trivial case of math with those values once we come up with them, and then interacting with them. And then maybe in order to go to the next scene, we need a certain number of experience points. So we can't go from the desert to the swamp until we've got at least 3 experience points or something, which again is just the basic logic conditions. So if we hit the gateway and the current scene is desert and experience points is greater than 3, so I guess we actually need 4 here, then we'll go to the desert. So hopefully what I was saying there makes sense and y'all can run with that. You can see it's trivial. It's the trivial math calculations and conditions on those sort of things that we just add into our game to make it a little more interesting for the character. So now we can't get to the next scene until we've kicked at least 3 of those guys. There's currently only 1, so probably need a couple more of them so that we can kick at least 3. So a quick way to do that is just maybe get the overhead view here. I'll select the background and zoom in on that, see the whole thing. And then just select that and copy and paste. Control C and Control V work. I'll use the right click for the example, but just copy that and paste another one and paste another one. And there's nice ways to organize that, but I'm just going to leave them here right now. So that gives us 6 guys, so we can just move those around the scene somewhere. Grab them one at a time and use the arrows to position them somewhere where our character can get over there and kick them. I guess ideally they would probably be moving too, right? But we saw how to do that. Maybe just a random timer works nice. Just choose a direction and then move in that direction for however some length of the timer. There we go. So should be just some guys just randomly scattered around. Yeah, it doesn't look like any of them are buried halfway in the hill or anything. But just copy and paste once that first one worked. And now we should be able to see something more interesting happen. Trivially more interesting, but hopefully you can see there why I was saying that that's a very trivial thing. So, but we can't go to the next world yet because our experience points, you see down here, we have 0 experience points, and we can't get to the next world until we have at least 3. But yeah, the collisions are happening weird here. I like raycast a little bit better, but we saw raycast last time and I wanted to include collisions. There's ways to clean them up. Sphere colliders might work better than box colliders for one. Since these guys aren't moving really, we could freeze the rotation so we're not pushing them around. Just need to push them up against something. There we go. There we go. So now we have 3 experience points, which still isn't enough to get to the next level. I can't get used to the world coordinates. That always throws me off. I want to look at the character and move the way the character is facing, not the regular north, south, east, and west. So still can't quite get to the next level. I think there were some more guys over here, yeah. And I guess playing around with that collider so that it works, get it to work more consistently would be good. Some of the options other than box collider might work better. Capsule collider, or the problem that's occurring there is whenever we bump up against him, yeah, then we had enough experience points to actually go to the next level. So it makes it so the more interesting things can happen. The problem there, if you want to try to mess with it, is whenever we bump up against him, the laws of physics are applied. So us bumping into him pushes him along. And then we're no longer pressed up against that collider. There's numerous ways to fix that, but with that being the problem in mind, maybe see if you can come up with something to fix it as time allows. I know the end of the semesters are always hectic, So we want to have lots of time to work. So before we jump over to time to work, I wanted to share something I found about these values. Well, I just mentioned, and hopefully that makes sense with the trivial aspect, that it's just basic math. We just apply them. So maybe our experience points are a multiplier of how much damage our kick does to the opponent. Or like we saw, experience points, a certain level of experience points are needed to get to the next level. The number of hit points we have would just go down when an opponent kicks us. And that's where the little tip I wanted to work in here kind of comes into play. Because sometimes that's nice, but if you're trying for realism, there's something that just seems a little bit off about that. And well, the general idea of the tip, the main core of it, is don't be afraid to try things. You don't have to go with it if it doesn't work, but if you don't try things, you're definitely not going to know whether or not it works. And the thing I was just describing always seemed a little bit off to me. Like whenever the opponent kicks us, our hit points go down by 3. Let's say that's what it starts at. And maybe we start with 20 hit points, goes down by 3, goes down by 3, goes down by 3. Then near the end, our character, the health bar and all that, maybe the animation that relates to it, shows that our character is really in bad shape. But then the opponent's punch would still do the same amount of damage it did when we were in full health, which that's a little bit off from realism. That was one of the things I thought seemed a little bit off. So what I wanted was ways to make that seem a little bit more realism. And the general tip is to try different things. And one thing I found that seemed to work really well is because, well, this is a good example of it in our real world. Money's a big deal in our real world, right? And that's why I left this up here. I'm going to erase it now. And excuse me for 1 second. I'm going to grab a paper towel to erase that. Sorry, what I was going to write on the board doesn't. The eraser needs cleaning. There we go. Chalk will probably show up on that now. But with money, that's a good example because money doesn't grow evenly, right? In the real world, we have, like in a savings account or a loan or something, interest is going to be applied. When you think about money, money grows and either grows or decreases with interest, not at a steady rate. But we would define it as sort of a steady rate. So things like how much damage it does, instead of just being strictly the same thing every time, I reached out and tried some different formulas, like the accrual formula that you've probably seen in math class. And if you haven't seen it, you will at some point, because pretty much every math class that you take, everybody has to see this in some math class somewhere. Not our simple interest rate, because you're probably well aware that that's not how interest really works. It just makes for an easy calculation, a good estimating value. The actual formula is the accrued amount is the principal, and then 1 plus that rate divided by however often it applies, raised to an exponent of how many times it applies. So I thought about this, in particular, compounding interest. Have you all seen that before? And well, with money growing, the longer it sits there, well, as the money sits there, we gain interest. And then it sits there longer and we gain interest, including on that interest we've already earned. So that as the money just sits there collecting interest, it earns more interest every time, because what we've already earned in interest now gets interest as well. And it grows more rapidly. So things like that example that I was using for the hit value, instead of just saying like the hit points minus equals 3 every time, I would apply something based off the compound interest formula. So instead of hit points going down by the same every time, it goes down by some value that kind of compounds. It's down by 3 and then 1 plus our current hit points divided by n raised to some exponent. And just apply this formula. So then as the character gets closer and closer to like really in really bad shape, right? Like they've taken a lot of punches in bad shape. The animations are showing them all bent over and coughing up blood and stuff. We would expect that a punch to a character in that shape would take more damage. So something like applying the interest formula will make it seem, it added back that touch of realism that I thought was missing from just doing the straight subtracting thing every time. And those are, well, they're messy formulas, but we really only have to program them once, right? And you could probably copy and paste versions with them programmed in, but they're easy things to find. I did a quick Google search to pull up a bunch of them. That is sort of a normal way for things to grow and shrink and different things like that. So we can get that more realistic effect of when we're hitting a more powerful character. Our stuff's not going to do as much, or when we're a more powerful character, the way it grows isn't necessarily linear. It grows similar to interest. And when I tried that, I thought it made a really nice effect. And you can just kind of search for them. I have the accrual formula up there, so I'll look for payment formula. And just go Google the financial ones. This one's kind of a mess. Yeah, we can see it there. So the rate times the present value divided by 1 minus the rate plus, or 1 plus the rate to the negative nth power. Kind of a messy formula, but doing things like that can make it seem a little bit more realistic. I searched for something earlier this morning that pulled up this nice site. I didn't really look at the name. I was expecting it to be purple. I thought that's what I searched for. Nope, and none of those results are purple. But you can just get this formula and apply that, and then use that on your trivial numbers. It'll make things seem a little bit more realistic. What did I search for this morning that brought back a really nice site? It might have been this. Oh yes, this is the site. So I searched for payment formulas, and then brownmath.com has this site with all kinds of explanations, but it also has just a list of formulas. And when we're programming, we can plug them in. So things like loan balance after so much. Instead of just linear combinations of your experience points and hit points, adjust how your hit points are affected by certain types of armor. Right? Different armors are going to bring in, and then that will be very, very similar to payments on a loan, right? The payments on a loan over time means we've paid more on that loan. And a similar thing with armor in a video game. More powerful armor would relate very similar to having made more payments on a loan. So formulas like that. The payment formula, number of times things happen, and yeah, messy formulas, but it should be somewhat straightforward to type them up in your code, and it will make a big difference on the general effect it has on stuff. That was one I found and like to do, especially just the interest formula for applying damage, because then base it off how healthy the character currently is. I think I wrote that wrong a second ago. 1 plus 100 minus hit points over the number of times. So that way, as the character gets weaker, I think I'm still writing that wrong. I'm confusing myself. But somehow subtract that, and I'm confused myself now. I have it typed up, so I just copy and paste from the previous time I typed it up. It's not something we have to do a lot. But as the player loses hit points, the damage applied from the next hit becomes worse, and it seems more realistic. I thought that worked out. The general tip, though, is don't be afraid to try stuff. Think about things, look, and I chose the financial example there because that's one I found that worked really, really well for me. So I reached completely into another field. Right? We wouldn't normally make that association between our hit points and experience points and the standard financial equations, but it worked really, really well for me. So don't be afraid to try things, think outside the box, look at other stuff that you know and interaction between things, and try to work that into your game. Because video games are simulations, but they are illusory simulations, right? It's not the like supercomputers trying to re-simulate the evolution of life to get an exact copy, right? That has to be very precise. With video games, we're doing the illusory simulation. We just want it to look like the thing that we're trying to simulate. So think outside the box. Financial equations I found worked really, really well for some of those interactions to get away from that linearity, because we know the world isn't really linear. Linear is nice and easy to calculate in math classes, but it quickly starts to look a little unrealistic in our games. So I want to leave you with that tip of think outside the box, stretch outside the field, and don't be afraid to try anything. Try new things. If it doesn't work, delete it and try something else. And that was pretty much what I had on tap for this class. Leaves us 2 hours of lab time, which is probably good with the final due date coming tomorrow. Probably lots of work to do. If anybody has any questions, don't worry about time. I don't sleep very consistently anyway. I'm usually up 5 or 6 times a night. So don't worry about time to get a hold of me between now and the due date. Just if you have questions, send me a question and I will help as soon as I am able. There's a couple things on the to-do list between here and there, but let me know if you get stuck on anything. For the next 2 hours, basically, I'm going to be sitting right here by the computer till 4:50 for our regular lab time, ready to jump back on a Zoom call in a split-second time if you have questions. Otherwise, you'll have a nice holiday break. Try to relax a little. It's been a busy semester, I know. So everybody have a good one, and I will see you in the spring, I guess.
All right. Hey, Chris, before you leave, I had a real quick question. So while